we're moving on to the next thing. We're going to solve by completing the square. We're going to finish creating perfect square trinomials. There's a lot going on. So for the next couple problems, I picked very nice trinomials, meaning we will not get decimal answers. It's more about the process on the first couple. Yes, there'll be easier ways to do it, but I like to show you with nice numbers. I also am going to write up here, just take a little side note. We have been solving two-step equations for a while, so if I have 2x plus 8 equals negative 10, I feel very confident. Many of you probably could solve this mentally, but I don't want you to do that for a reason. What we would do first, do the inverse, and we would subtract or put negative 8, excuse me, on both sides. So I would have 2x equals negative 18. Then I don't want 2 x's, I want 1, so x equals negative 9. Whatever we did to the left-hand side of the equal sign, we did to the right-hand side of the equal sign. That's what I need you to remember. We're getting into different types of problems, but it's the same philosophy. Okay, when we had this problem in our last unit, and I'm asking you to solve, that means we have to set it equal to 0. So I would add 12 to both sides, similar to our side note, and I would get x squared minus 18x plus 17 equals 0. Because the a is 1, I need two numbers that add to negative 18 but multiply to positive 17. Negative 1 and negative 17 would work. So x minus 1, x minus 17 equals 0. Set each one equal to 0 and solve. So one root, one x-intercept would be 1. The other would be 17. Those are your roots. If we graphed, those would be my x-intercepts. Okay, we are going to pretend that we got to this stage, but we were in a prime situation. We're not going to be in prime situations anymore. What we're going to do first is I'm going to rewrite this equation here. I'm not going to write very big. I for sure did not allow myself too much room. But what we're going to do is we're going to create a perfect square trinomial. That means I'm going to subtract 5 from both sides. So I have x squared minus 18x. Oh, I got rid of that number. So now I am missing my c. I don't know what it is. I got rid of it. Equals negative 17. Using our 3 steps that we kind of did right here, we're going to find c and make it a perfect square trinomial. Step number 1, take half of b. Step number 2, take your answer from step 1 and square it. Step 3, this is where we're going to do something a little different. Put this answer into the equation for c. Now, please realize I added 81 here to the left-hand side of the equal sign. So I need to add 81 to the right-hand side of the equal sign, just like the two-step equation. When you're subtracting 8 from the left, you subtract 8 from the right. When we divide by 2 on the left, divide by 2 on the right. If I'm going to add 81 to create a perfect square trinomial here, I have to add 81 over here. Now, I have a perfect square trinomial, So I would have x squared, x minus 9, square root of the first term, square root of the last term, sign in front of b, squared equals 64. I added those two numbers together. Going back to the square root property, I have to take the square root of both sides. So x minus 9 equals the positive 8. X minus 9 equals negative 8. Therefore, x equals 17. X equals 1. Well, that worked out beautifully. I am not surprised by my answers, but like I stated, I wanted to start with nice numbers. So I'm going to ask you to pause the video a minute and just reflect over all of the stuff we did right here. There is a lot going on. So please just take a moment, pause the video, look at what we did. Yes, if we can do this, please do it. It's easier and faster. Take a moment, look at what we did, think about the steps, and then we'll move on. Thank you for pausing the video. Please, let's move on to the next problem. I will say to you, please see if you can factor it what we know how. Can I find two numbers that add to negative 8 but multiply to negative 84? Sure, I can. That would be, let's see, negative 14 and 6. Ooh, that works well. So I will have x minus 14 times x plus 6. Set each factor equal to 0. My two roots would be 14 and negative 6. Now, like I stated, we're going to start with those simple ones before we dive into the decimals. I'm going to pretend that I couldn't factor this. I'm going to create a perfect square trinomial by binding and making c. So I need to add 84 to both sides, so I get x squared minus 8x plus c equals 84. Now I will follow those 3 steps from the other page. Step 1, half of b. Step 2, square your answer from step 1. Step 3, put 16 in for c. I would have x squared minus 8x plus 16 equals 84. But if I add the 16 there, I have to go over here and add 16. Great. Perfect square trinomial. We know that. We just did it. So I would have x minus 4 squared equals 100. Well, this turned out marvelously. Square root property. X minus 4 equals positive 10. X minus 4 equals negative 10. X would be 14. X would be negative 6. My x-intercepts would be those two numbers. Now on the next ones, we could test it. I could bring that over here and I would get negative 11. Can we think of numbers that add to 16 but multiply to negative 11? Because I would subtract 18 from both sides. I don't know of any. Again, in our prior unit, I would have let you say prime, but we're moving on. We're not doing that anymore. So that means I know my answer is going to be a decimal. So I'm going to move the 7 over here. And I would get x squared plus 16x plus a c that I have to figure out. I'm going to make a perfect square trinomial equals 11. We will use our 3 steps. I'm going to take half of b. I am going to square my answer to get 64. And then I'll just put that in for c, and I would get x squared plus 16x plus 64 equals 11. But if I add 64 here, I have to add 64 there. We have now created a perfect square trinomial, so I would have x plus 8 squared equals 75. You will definitely need your calculator for this. Square root property, x plus 8 equals negative square root of 75. X plus 8 equals positive square root of 75. Well, I need my calculator, so I would subtract 8 from both sides. And negative 16.7. And then I would add the square root, and I get 0.7 tenths. Not leaving a whole lot of room to work, let's just try to squeeze one more in there. I don't think I could come up with numbers that add to negative 24 but multiply to 9. No way. So I will subtract 9 from both sides. So I have x squared minus 24x plus c equals negative 9. We need to do those 3 steps. Half of b, square your answer, and then put your answer that you got from step 2 back into the equation. If you add 144 to the left-hand side of the equal sign, you need to add 144 to the right-hand side of the equal sign. We have now created a perfect square trinomial. We will take the square root of both sides. Man, I apologize for not leaving you much room to work at all. Either that or I write really big. And I would get x minus 12 equals the negative square root of 135. X minus 12 equals the positive square root of 135. I would add 12 to both sides. My 2 roots, I've used my calculator. I know the answer. For this one, I would get 4 tenths. Please check it on your calculator. For this one, I would get 23 and 6 tenths. That's a lot. I would like you to pause the video and do the next 3 problems. 1, 2, 3. Don't move ahead. Pause the video and do the next 3 problems. All right, my apologies for creating such a hot mess for you. I will, when I print yours, make them a little more spacious. For the first one, I have roots of 14 and negative 2. For the second one, I ended up with roots of negative 15.6 and 1.6. Finally, for the third one I asked you to do, I have negative 31.1 and 1.1. Please pause the video, take a minute, compare our work if we have different answers. Did you do what I did? What did we do different? Email me anytime that you have questions. Before you let the video go out, go ahead, hit pause. If you and I have different answers, figure out what we did.